All right, mathematicians, we're looking at compound inequalities. Now we've got this number line where it's already graphed, and so we're trying to figure out what inequality or inequalities would represent this. So for this first part, we include the negative 1, and then it's everything to the left of that. So that will be x is less than or equal to negative 1. And then at 2, we're not including the 2, but it's everything to the right of 2. So we'll put the word or in between these. There are not values that are greater than 2 and at the same time less than or equal to negative 1. So it's the word or that would join those together. Now on number 2, looking at the negative 1, we're including negative 1 and then we're shading to the right of that. So you might say x is greater than or equal to negative 1. But then when we look at the 2, it's to the left of 2, so you might say x is less than 2. Now, on this graph, those values fit both of these, so we would use the word and. Now we can also write it a little bit simpler. If we switch sides on this first inequality, if x is greater than or equal to negative 1, then negative 1 is less than or equal to x. And then if we put that together with what we have over here, we can say that x is also less than 2. And so it gives us this inequality where there's two numbers and the variable in between them. That variable is between negative 1 and 2, including the negative 1, not including the 2. So that's the simplest way you could write that. All right, here we want to solve this inequality, this compound inequality. So to get rid of minus 3, we'll add 3. 11 plus 3 gives us 14. So 2x is greater than 14. To get rid of multiplying by 2, we'll divide by 2 on each side, and we have x is greater than 7. Now to get rid of the plus 1, we'll subtract 1. Negative 9 minus 1 gives us negative 10. So 5x is less than or equal to negative 10. To get rid of multiplying by 5, we'll divide both sides by 5. And we get x is less than or equal to negative 2. These are joined by the word or. So if we think about a number line, we're including all the values to the left of negative 2, including negative 2. And then we would also be including not 7, but all the values to the right of 7. Now, I'm not too picky about this, but you can talk to your teacher to see. You might need a negative 3 here just to show that you know what these mean. So these cannot happen at the same time. It's joined by the word or. It's a union of those two inequalities. All right, this time we'll subtract 3. That gets rid of the plus 3. So we have 4x is less than or equal to 4. And then to get rid of multiplying by 4, we'll divide by 4, and x is less than or equal to 1. On the second one, to get rid of multiplying by a negative 3, we'll divide both sides by a negative 3. One thing you have to remember with the inequalities is if you multiply or divide both sides of the inequality by a negative, you have to reverse the inequality symbol. So when we look at these values, we're talking about an or here. It's a union of these two. The green ones, we'd have a solid or a colored in circle at 1 shade to the left. For the red one, we would have an open circle at 2 shade to the left. Now for the union of these two sets, we're including any part of the graph that has is shaded at least once. So instead of writing both of these, we can just write x is less than 2 for our final answer. And the graph would be according to that. So for an or, it only has to happen at least once. All right, on this one, to get rid of multiplying by 7, divide by 7. Be that x is less than 5. For the second one, we're going to distribute the 9. 9 times x is 9x. 9 times minus 1 is minus 9. 2 steps from here. To get rid of minus 9, add 9. And so we have 9x is greater than 27. To get rid of multiplying by 9, we'll divide by 9. And we'll have x is greater than 3. This is an and. So we want all the values that are greater than 3 and at the same time less than 5. And so our graph will be the values between 3 and 5. So 3, the decimal values in between there, like 3.1, 3.9, all the way up to 5, but not including 5. So 4.9 would be included, but 5 would not. All right, on this first one, we've got some like terms we can combine. And so 2x minus x is 1x, or just x. So x minus 8 is less than or equal to 2. To get rid of minus 8, we'll add 8 to each side, and we'll have x is less than or equal to 10. On the next part, we're going to divide both sides by 4, and we get x is greater than or equal to negative 1. Notice that we were dividing both sides by a positive here. So we want all the values that are greater than or equal to negative 1, and at the same time, less than or equal to 10. And of course, all those values in between there would be part of our solution set. All right, to get rid of multiplying by a negative 3, we'll divide by a negative 3 on each side. We'll have x is greater than negative 10. Don't forget to reverse that inequality symbol. To get rid of plus 7, we'll subtract 7. And so we get 5x is less than or equal to negative 10. To get rid of multiplying by 5, we'll divide by 5 on each side. And we get x is less than or equal to negative 2. This is an or, so we'll join these together. So if we think about greater than negative 10, so not including negative 10, but shade to the right of that. And then if we do it on the same graph, less than or equal to negative 2 would be here, and then that would be shaded to the left. For an or, it just has to be shaded one time. So the whole graph ends up being shaded, and so we call this all real numbers. Any real number we choose will be part of our solution set. So your graph just looks like the whole number line shaded, and you can use the words all real numbers to describe that set. All right, here we've already got it written as what I would call like a three-part inequality, two numbers and the variable in the middle. Now we don't have it solved for the variable yet. So think about where the variable is. To get rid of division by 2, we need to multiply by 2. Well, if we do that in the middle, we got to do that on the left and the right sides. So we get negative 12 is less than x plus 3, which is less than or equal to 24. To get rid of that plus 3, we'll subtract 3 from each side, both from the middle and the left side and the right side. So we get negative 15 is less than x, which is less than or equal to 21. So on a number line, we're looking at not including the negative 15, but everything to the right of that until we get to 21, and we will include the 21. So this x is already written between negative 15 and 21, not including the negative 15 because we don't have the or equal to, but including the 21. All right, we've got this word problem here. So zebra is going to eat between 15,000 and 20,000 calories a day. And the way that the zebra is going to do that is they're going to eat 14,000 calories of vegetation. Plus some fruit snacks. The frozen fruit treats are 250 calories each. So if we let x represent the number of fruit treats, then it'd be 250 times that. And so the daily calorie intake has to be between 15 and 20,000 according to the diet. So we've got this inequality, and so we'll subtract 14,000 from the middle, from the left, and from the right. So when we do that, we get 1,000 is less than or equal to 250x, which is less than or equal to 6,000. Now to get rid of multiplying by 250, we'll divide by 250. If we do that in the middle, we got to do that on the left and the right sides. So when we do that, we see that the zebra can have anywhere from 4 to 24 of those fruit snacks every day. All right, hopefully this video is helpful as you learn how to solve compound inequalities. Oh, I should mention one other thing. It is possible to have no solution. Let's consider this one. Let's suppose that x must be greater than 5 and x must be less than 1. So it's an and, so both have to happen at the same time. If we think about that on a graph, it would be everything to the left of 1 and at the same time to the right of 5. That can't happen, so we would say no solution. So just keep in mind that for an and, you can have no solution as well.